We've looked at unbalanced forces that had to do with just the forces acting on an object moving to the left and to the right. We've looked at unbalanced forces when we had a vector force. What we're going to do now is we're going to look at forces when we have something on a ramp. What are the forces going to do here? In this situation, what is this going to look like? Well, first of all, is this box going to move down this ramp? Well, if it is, what's going to cause it to move? It's going to be gravity, which is going to move straight down. This is going to be the force due to gravity. Now, if we're looking at this box, one really convenient thing we can do in order to examine the forces here is we can think of this as if it's flipped. So if I move this so that my inclined plane is now my horizontal surface, I can see exactly how this is going to move. I'm going to have some part of my gravitational force will be going into the inclined plane, and some of that force will cause this box to roll down the plane. Now, what else am I going to have here? Well, I'm going to have a force normal that's going to be directly opposite the plane. It's going to be perpendicular to that inclined plane, and I'm going to have force of friction. So we're going to have a force of friction here, force normal, a force of gravity that's going to be, let's say, parallel to the plane. So we'll draw a parallel symbol here. And we're going to have a force of gravity that is perpendicular to this plane. So once we do that, well, then put this back to normal. And we can see all of our forces that are going to be acting on this box. Now we can try and balance this. So first thing we need to do here is we need to consider, how is this force of gravity going to get split up? What is this triangle, and what angle is going to be in this triangle? Well, if I look at it this way, I've got this guy right here, and we're going to have this perpendicular force, or this parallel force. This is going to be the opposite. This is going to be the adjacent. And the force of gravity is going to be my hypotenuse. And what is this angle going to be? Well, that's going to be the same angle as the ramp. This angle right here is going to be this angle right here. So when we solve this, all I need to do is split up my force of gravity properly, and then I will be able to figure out everything from there. Now, the force normal in this problem is going to be the opposite of the force of gravity perpendicular to the plane. It's not going to be the full force of gravity. So that's another thing we're going to have to remember. So far, we've had 3 different ways we could think about force normal. Hopefully, you're starting to see that this is going to be a concept that we have to think about. We have to think about, how is this force opposing another force? We can't just plug and play some numbers. We have to think about it a little bit. So let's put some numbers to this, and let's start to work. Let's say that the mass of the box is 50 kilograms. And let's say that this angle right here, let's say that this is, let's give it a nice steep curve so that we know that it'll move. Let's say 70 degrees. And then let's give the force of friction, the mu k, let's give that a 0.3. I'm really exaggerating these numbers to make sure that this is small and this is large so that we actually get a net force on this box. So let's put, what's the first thing we want to figure out here? We want to figure out the force of gravity first. So we're going to have the force of gravity, then we're going to have the force parallel, the force perpendicular, force normal, force of friction, and finally we'll be able to find F net. So force of gravity, that should be my 50 kilograms times about 10, so we'll go 500. 500 newtons thanks to gravity. What's going to be my force parallel? Well, we've established that the parallel would be the opposite side from this angle, and this angle is still going to be 70 degrees. So my force parallel, let's even do this in the same color, my force parallel is going to be equal to the force of gravity times the sine, because sine is opposite over hypotenuse, the sine of theta. So when I plug my numbers in, what I'm going to get here is 500 times sine of 70 will give me that number. Let's calculate it. And so for my force in parallel, I get 469.8, so let's round that to 470 newtons. And then the force perpendicular, that force perpendicular will be equal to the force of gravity. Now this is the adjacent side, so it's going to be the cosine of 70. So we're going to take that 500 times the cosine of 70. And we're going to get 171 newtons. Now my force normal, that's going to be the opposite. It's going to be the force of the ramp pushing back on this box. So it only cares about the amount of the gravity of this box, the amount of the weight of this box that's actually pushing against the ramp. That force parallel is not pushing against that ramp. So the only thing pushing against the ramp is the force perpendicular. So we're going to have the perpendicular force will be equal to negative force normal. And so let's get our signs right here. I'm going to say that the force perpendicular is going down. I'm going to say that is my negative. I'm saying going to the left is positive, so that going down the ramp is positive, and my force of friction will be negative. So I'm going to put a negative sign right there right now so I don't forget to later. So my force normal will be then positive 171. 171 newtons. And now my force of friction is going to be my force normal times my mu k, which is going to be 171 times 0.3. There we go. And I get 51.3 for force of friction. 51.3 newtons. Now I can find my F net. My F net is going to be the net force going down this ramp. So F net equals force of friction plus force in parallel. Now when I do that, I've got 470 minus 51.3. And that gives me an F net of 418.7. And that's how we solve problems related to an inclined plane. I have another problem set up here. I have a mass of 100 kilograms, an angle of 25 degrees, and a mu k of 0.4. Let's see what net force we're going to have here. First off, I'm going to find my force of gravity by taking my mass times 10. So my mass times 10 will give me 100 times 10, which is 1,000. Then my force parallel, this will be my force of gravity, times the sine of 25. And that's going to be found because my force of gravity is going to be moving straight down. My force parallel will be the component of that gravity that is moving parallel to that plane. My force perpendicular will be the force of gravity that is perpendicular to that plane. So this angle right here, this one right here, is going to be the same angle as right there. And so my parallel force is going to be the opposite side, therefore I use sine. This is one that I usually have to be intentional about because I feel like parallel is more like x, and I usually associate cosine with finding x. But it's not in this case. That's why we need to keep in mind SOHCAHTOA. We need to actually know what that means. So we've got the sine of 25 and the cosine of 25. So let's calculate those two forces. So I get 422.6 and 906.3. So now I can find my force normal. That's going to be the opposite of my 906, of my perpendicular force. We're going to find this one as negative. And so my force normal will be a positive 906.3. And now I can find my force of friction, because that will be my force normal times my mu k. Which in this case will be 362.5 newtons. And then my F net, that should be negative by the way, my F net will be my force of friction plus my force parallel, which should be negative 362.5 plus 422.6. And that'll be a total net 60.1 newtons. So we should have a pretty good idea of how to solve these types of problems now.